Good morning, all of you. So, as we know, last before class we studied discovery of electrons and as well as what is the name of electrons we used to call what rays it is. Everybody, they are called as
Cathode ray.
cathode rays. So, to prove that atoms or matter contains these electrons, Mr. J. Thomson has been conducted an experiment through discharge tube and a 10,000 volts potential difference with a low pressure. So, at the low pressure, gases will conduct the electricity very faster, and it has been noticed that the opposite side of cathode it is producing fluorescence. That is what a faint greenish color light. So that is what we will say cathode rays. Yes or no? Everybody clear?
Yes, sir.
Yes, sir.
Yes, Aswardhan. Aswardhan, okay. Change your name. So that's fine. Now, today's class we'll see how this discovery of protons takes place and anode rays. So for this also, we are going to take the same cathode tube only, but the only one change it is happening. What is the change it is happening? Anybody? Yes, please. Instead of normal cathode, we are taking a separate kind of cathode. What is that cathode we are taking? Everyone. Yes.
Perforated cathode.
Yeah. So we are going to take a cathode name called as perforated cathode. What do you mean by perforated cathode? Everybody. So this is what we used to call as cathode. So but cathode is having what? They're having the small punches, or we will say canals, or we can say holes. So that is what we used to call as canals, or we will say holes and all. So this is the only difference between cathode experiment and as well as this one for producing anode rays. So now let us see how this experiment has been conducted and how it has been proved anode rays is a positively charged one. So now if you notice who has been conducted this experiment, discovery of anodes. Discovery of anode rays. And who has been done? Mr. Scientist name called as what? Yeah, using Goldstein. Okay, so using Goldstein is the scientist who conducted this experiment with only one difference. That is what? Perforated cathode. And he has taken one anode here, and this is the perforated cathode. So, opposite to the anode, he observed the color. What is the color he noticed? Opposite to the anode, he noticed the color what?
Red color.
Red color.
Yes, sir.
And opposite to the cathode, he noticed the color. What is the color he noticed? Yes, please. Opposite.
Faint green.
People know.
Faint greenish color.
Yeah, faint greenish color. So that is what it is. So from the anode, we all knows that it will be releasing the positive one. So that is what positive charge is going and striking through the perforated cathode, and it is producing a reddish color light at the walls of the cathode. Now, as we all know, a cathode is producing the electrons. So these electrons will travel and they will produce a greenish color coating at the anode, behind the anode. So this is what we studied in the last class. Now let us observe this schematic diagram very clearly so that it will be easy to understand. So this is what the diagram exactly, if you want to notice for this schematic diagram of perforated cathode and production of anode rays. So a cathode rays from cathode, positive rays from whom, guys? From anode.
Anode.
So that is what we can say. Positive rays from anode, cathode rays from cathode. So you can notice it here. Negative charged particles, they are moving away from the cathode and they are forming here. What color they will form, guys? a greenish color one. Correct or not?
Greenish blue.
Yeah, light greenish blue color coating it will form. Now, from anode, a positively rays from anode, they are going and they are passing through the what kind of cathode it is? Everybody, perforated cathode. If you notice a small dots, the dots indicating holes, and it will form what color it is? Yes, please.
Red.
Red color. So red fluorescence we can say. So it will form red fluorescence behind the cathode. That is what it is. How this experiment anode rays has been discovered. So this is we can say red fluorescence is produced here by whom guys? Anode rays or cathode rays? Anode rays.
Anode.
That is, and here a greenish color, a greenish glow, that is what fluorescence produced
By cathode rays.
by cathode rays. Okay, that is what the experiment. So, what has been done? A scientist name called as Eugen Goldstein. He has been having a perforated cathode to produce this anode rays. So just he has taken instead of normal cathode, the cathode which is having the holes or canals we can say. So that is why the rays were moving exactly opposite to the cathode rays. That is the reason Goldstein concluded that they were composed of what charges? Everybody, here you notice it. See that they are moving opposite to the exactly opposite to the cathode rays. So that is why Goldstein concluded that they are having what charge, guys? All of you, they are having positive charge. That is why he named this rays as channel rays because as it is passing through the holes, we used to say channels. Okay, or channel rays, or we will call it as a canals. That is why he called it as canal rays. Clear, Harish? Okay, now as they pass through the holes or channels present in the cathode, that is why we will call them as channel rays or canal rays. Now, the actual nature of this particle of canal rays is not found by Mr. Goldstein. Do you understanding? Later, it was found in 1907 when these rays were treated under magnetic field. You will study in class 11 this is when these rays treated under the magnetic field, that is what properties of anode rays, then only they have been found. That experiment, when you treat these rays with a strong magnetic field, then it has been revealed that all the particles of anode rays do not have what, guys? Anybody? Do not have same mass. Do you understand, all of you? So different particles is having different mass. That is what has been found it. So that is why the lightest one was found when hydrogen gas was used in the tube. Understand, Mitakshri, what I am saying? Okay.
Yes, sir.
Electrons, whatever the gas you will use, they found that all the mass is what? All the mass is what? Mass is same. Understanding? And that is what we say. What is the mass of the electron? Everybody? 9.1 into 10 power minus 31 kilogram. So this is the fixed mass of electron. So if you take any kind of gas, the mass of electron is remains constant. But if you have taken positive rays, anode rays, is it all the things are same mass? Everybody? If I have taken hydrogen gas inside the tube, different mass, different gases, different mass. That is what has been found it when we are conducting the experiment with these anode rays and magnetic field. So The anode rays obtained from the hydrogen gas. If I pass the hydrogen gas inside this tube, then it has been found that the smallest positive particles are coming. Means who is having the very lightest one. So the lightest one was formed only when the hydrogen gas was used in the tube. So when we used hydrogen gas used in the tube, so we have been found a lightest particles are coming. So the anode rays obtained from hydrogen gas are composed of same type of positive charges, positive particles. So that particles only we used to called as, what is that positive particles? Everybody called as what? Yes, please.
Protons.
Protons. Understand all of you? So they found that they do not have same masses. Where who is which particles giving the lightest mass? Lightest one. Yes, please. When we are passing the hydrogen gas inside the tube, then all the particles which is released during the hydrogen gas, all having the same type of positive particles. That is what they called as protons. Have you all understand? Please let me know. Clear, guys? Everybody? So this is how this protons or positive charge particles has been discovered with the help of perforated a perforated cathode. Okay, everyone. So now let us see how and why this cathode and anode rays are produced. Let us discuss that. Shall we discuss all of you? Is it okay? Mr. Harish, Umar. So this is the
Yes,
experiment
sir.
conducted by Mr. Goldstein. So how he has been conducted and what way they discovered, everything is clear. Now we are going to study how and why this cathode and anode rays are produced. Let us discuss that. Okay. So we are all studying when we connected to when we are seeing that opposite to the anode, red color, a dim luminous rays, and opposite to the cathode, we are noticing the greenish glow light. So we are saying one is positive rays, one is negative rays. Then why it is happening? What is the cause behind it? Let us discuss that. Shall we start now? Everybody, so keep reading how and why the cathode and anode rays are produced. Make it. Shall we start? All of you? Now,
Yes, sir.
discuss what is the cause of producing cathode rays as well as anode rays. Okay. So any doubt, Johan? Anything, please ask me. Mr. Sanjay, Gokul, anything doubt? Clear? Shall we proceed now? Ashwin Balaji. Now, let us observe when a gas is taken in a discharge tube, what will happen means. So, let me take a normal discharge tube, just I am saying. So, I'm not taking any cathode, anode, or whatever it is, just I am taking. So, when a gas is taken in a discharge tube and the electric discharge is given under very low pressure, that is what it is, yes or no? So, I filled with this discharge tube with a gas, some gas. Now I am passing the electricity with low pressure or high pressure. Everybody, electric discharge. Yes, please. Electric discharge means transferring of charge through solids, liquids, or gases. That is what we used to call as electric discharge. So electric discharge is taking place under very low pressure or high pressure. Everybody.
Low pressure.
No
Under
pressure,
low
sir.
low pressure. Okay. Now what will happen means, first of all, this gas breaks into atoms. That is the first thing will happen. So why this cathode and anode rays are producing means, whenever this electric discharge, how many of you know what do you mean by electric discharge? If you don't know, I will say. I already told you just now, but can I say once again? Electric discharge means nothing is there. Transfer of charge through solids, liquids, and gases is only called as electric discharge. Class 8 will come. Class 8, some natural phenomena chapter, you will get it, what is electric discharge. So, as we are passing electric discharge under very, very low pressure, so what will happen? First of all, this gas will breaks into atoms. Are you understand, Harish? Sanjay Ganan? Clear? So these are all the gas particles, whatever they are present, they all will breaks into atoms. Now, if further discharge is given, then what will happen? The electrons are knocked out from the atoms to give cations. So that is what will happen. So still continuously, when I pass the electricity, first gas will breaks into atoms. Still I am passing electricity. Then what will happen? If I continue this further discharge, then first of all, the electrons, they will knocked. Knocked means, as we all knows, they will be revolving around the atoms in a particular orbit. So they will get the energy to come out from the atoms. That is what will happen. So electrons knocked out. Knocked out means just send it out from the atom. Okay. So from the atom to give what ions, guys? Everybody, to give what ions? It will give you cations. Clear? Now, all these cations are attached to the negative cathode, and few of them pass through the holes of the perforated cathode. So that is why these cations from the anode rays and the knocked out the electrons from the cathode rays. So observe, first if I pass the electricity, first all the gas will breaks into atoms. If I further passing the electricity, the electrons will come out. They will be knocked out from the atoms and they will form the cations. Now, these all the cations. What will happen? Every cation, you can take cation, all the cations, they will attach or they will be attracted to the whom, guys? Negative charge or positive charge? Anybody? Cations. Please respond.
Positive charge.
Yes. Cations are positive charge, but they will be attracted towards the whom?
Negative side.
Negative charge.
Who is the negative cathode? All cations attracted to the whom? Attracted to
Anions.
negative cathode. Who is that negative cathode called as? Yes, please. Negative cathode. Understanding? That is what cathode we can say. Negative charge. Is it right or wrong? All of you. Yes, please.
Yes, sir.
Yeah. Remember, anions, negative charge. Anode which charge? Positive charge. Same way, cations, what charge? Cations, positive charge.
Positive charge.
But cathode is a what?
Negative charge.
Negative charge.
Cations will attract cathode, anions will attract anode. That is what you have to remember. Okay. So once all the electrons are knocked out from the atoms, and these all the cations will form. These cations, they are attracted to the negative cathode. As we know in this experiment, some of the cathode is not just a cathode. What is the cathode we have taken? Everybody? We have taken the
Perforated cathode.
perforated cathode. So what will happen? All the cations will come towards this cathode and some of them they will pass through this. Are you clear, everybody? Understanding, Amma? So through the holes or canals. So these cations which are passing through the perforated cathode, they will form the rays called as, what is that rays called as? Where? All of you?
Anal
Anode.
rays.
Understand? Anode rays, and they knocked out electrons from whom? They knocked out electrons from whom? From the cathode rays. Understand, all of you? So from the cathode rays, they will just knock the electrons and they are attracting towards to the anode, towards to the cathode, and some of them they will pass through the channels or canals and they will form what rays we used to call anode rays. Understanding? So these cations form the anode rays and they knocked out electrons from the cathode rays. So that is how when electricity passes through the gases, first atoms, the gas will break into atoms and the atoms further knocked out the electrons to form the both cathode rays and as well as anode rays. That is how it will be happening. So now, suppose if I have taken inert gas, then what will happen? All of you observe. We all know inert gases. Can you tell me what do you mean by inert gases? You might be studied in class 7th, class 8th and all. Yes, please. I want to know. Any example of inert gases? Yes, please.
So like atom.
Yes, inert gas. Inert gas, or we can say noble gases. Have you heard this word, all of you? Abhirami?
Yes, sir.
Yeah. So inert gas or noble gas, which we can say unreactive gas. What is this? Unreactive gases. Okay. So which are very stable in nature. So we are having so many gases, like we can take helium, neon, argon, okay, krypton, krypton, xenon, like this. So these gases, we will say inert gases, means unreactive gases. Now, you can notice it, when an inert gas is taken in discharge tube, then what will happen? Observe very carefully. If I have taken inert gas, okay, so now the tube is completely filled with the inert gas. Now, if you notice it, here, these inert gas directly convert into cations. Do you understand, everybody? So whatever it is, if you have taken inert gas inside this discharge tube, so all the atoms directly convert into cations, okay, and the electrons. That is what will happen. Electrons means what? Cations means anode rays, and electrons means what rays, guys? Electrons means what rays?
Cathode rays.
Okay, that is what. So this is the same principle we will use in our daily life also. You might be heard a neon sign lamp. Actually, we will use in our like olden days and all. We people use a neon sign lamp. So actually, this will work in the same principle. The whenever we fill this neon gas, neon is a what gas? Here you can see here. Neon is a what gas? Inert gas. So whenever we will use this neon gas in this neon lamp, yeah, completely atoms directly converting into cations and the electrons. So the same principle it will use. But under normal pressure, gases do not conduct electricity. That is why what we have to do? We have to create what pressure, everybody? We have to create what pressure? Yes, please. Low pressure. Understanding? Sir, what will happen if I keep normal pressure? So under normal pressure, what will happen? Observe. Under normal pressure, gases do not conduct electricity. Okay? Gases do not conduct electricity. That is why we can say them. Poor conductors are good conductors. Girls, boys, Gases are poor conductors or good conductors? They are the poor conductors.
Poor conductors.
When we are passing the electricity at the normal pressure. So what is the reason? Because under the normal pressure, these gases, the particles are close to one another. So that is the reason they cannot conduct electricity. Particles are close to one another. That is the reason they do not conduct electricity. Please note that. So that is why the ions formed and they recombine to give the neutral atoms and molecules. So it is not possible to conduct the produce the anode rays or cathode rays when at normal pressure. So that is why we have to create how much pressure. We know that Mr. J.J. Thomson created approximately how much? 0.01 ATMs. Yes or no? So extremely small pressure. So at this time only it will be possible to produce the ions, that is what cations and electrons. So otherwise these particles are close enough so that they will never turns into ions. Is it clear, Amma? All of you? Yes, please.
Yes, sir.
Now, and one more thing you observe. Suppose if I fill this tube with why I am filling with inert gases? Because inert gases directly they will convert into what? Everybody. Directly they will converting into
Cations.
cations and as well as electrons. But if I take normal gas, suppose let me take hydrogen gas. Can you tell me what is the hydrogen gas formula? Chapter 3 we studied hydrogen gas formula. Hydrogen gas is taken. So what is the formula? Anybody? Yes, please.
H.
H2. Understanding? Hydrogen gas is taken. That is what? H2. Okay. Now, so if I taken in a discharge tube, how it will be happening? You observe. So if you take any kind of gases, first what will happen? Gas will break into what? Atoms. Atoms only break into what? Everybody. Cations plus electrons. Understand, Mitaksri? Clear? Normal gas.
Sir.
But if you have taken inert gases, what will happen? Inert gases, for example, if I take helium gas, He, so if I take in a discharge tube, directly they will convert into what? Helium gas. Directly into what? They will converting into cations plus electrons. Understand, Harish? Noor? That is the difference between normal gases and inert gases. Is it okay, guys? Yes, please.
Yes, sir.
So let me take hydrogen gas. What will happen first? So if I have taken hydrogen gas at low pressures, electric current is passing. Electric current is passing at low pressure. Low pressure. First, it will produce atoms. Understand, everyone? Abhirami? It will produce atoms first. Gokul, see that. Now this is H2 molecule, but here what? Hydrogen atom. Understand, Amma? Please respond. Now, this hydrogen atom, further if I continue, electric current with a low pressure or high pressure, all of you? Yes, please. Electric current at low pressure so that it will turns into what? Cation. Can you tell me what is the cation of hydrogen? By loss of electron, it will turns into what? Nobody. It will turns into H plus 1 electron minus 1. That is what will happen. So H plus anode rays and 1 electron is a cathode rays. That's all it is. Clear, all of you? Yes, please.
Yes, sir.
Any
Yes,
doubt?
sir.
You can ask me. If I take an hydrogen gas, first gas into atoms, then further atoms into cations plus electrons. But if I taken helium, what will happen? If I take helium gas, directly they will convert into what, guys? Yes, please. Taken, then directly they will convert into whom?
Cations.
Cations directly. So that is what the principle where these neon lamps will work. Okay, so electric electric current directly at the low pressure. So they will converting into helium plus 1 electron minus 1. So that is how it will be happening. So hope you all understood this one, how and why this cathode and anode rays are produced. Is it clear? Anybody having anything doubt, you can ask. All of you understand? Abhirami, Gokul, yes, Daniska,
Yes, sir.
that is. So that is how we are producing cathode rays and as well as anode rays. And all of you remember, the electrons always will represent with a negative charge. So electrons are represented by E minus, and same way protons are represented by P plus, or we will represent with the P. So this is the symbolic representation of electrons and as well as protons. Okay. Now, if an atom, if you have taken, is a fundamental material particle, so or a subatomic particle carrying unit positive charge, we can take, all of you observe, the charge of proton also same. What is that? 1.6 into 10 power minus 19 coulomb. Charge of electron also how much? Same. What is the charge of one electron? Anybody? 1.6 into 10 power minus 19 coulomb. But this is negative. But what is this one, guys? All of you? This is positive. That is your
Positive.
clear. Now, what is the mass of one electron? Everybody, mass of one electron, how much? Yes, please.
9.1 into
Yes.
10 power minus 31
9.1
kg.
into 10 power minus 9, minus 31, sorry, minus 31 kg. Okay. Now, if you have taken a 1 unit of positive charge, then the mass is 1.67 into 10 power minus 27 kg. So, if you have taken, who is bigger? Proton is bigger or electron is bigger? Anybody? Yes, please.
Proton, sir.
Proton mass is bigger. Do you understand, all of you? So don't think that this is 9.1 and this is 1.67. So which value you have to consider? Anybody
Power, sir.
understanding? So here power is minus 31, and here what is the power? Everybody,
Minus 27.
Minus
20.
27.
So that is what mass of proton. Have you noticed that charge of electron and charge of proton are same but opposite, but mass. Is it mass is same or different? Everyone, mass is same or different?
Different.
Different mass. Do you understand? That is why when we are calculating chapter number 3, understanding that atoms and molecules, we are studying mass number. Mass number means we will consider, I will remember that mass number will represent with a A. Mass number will say only number of protons plus number of neutrons. Is it yes or no? All of you? Yes, please.
Yes, sir.
Yes, sir.
Compared to the mass of proton, mass of electron is negligible. That is why we won't consider mass of electron in mass number. But every atom, remember, number of electrons is equals to number of protons. That is what we will call some number. Anybody can tell me what is that number? Chapter 3 you studied. Anybody, girls or boys? Who is to call something that number? Anyone? Harish? Atomic number. Understanding? Atomic number. So that is what will represent with the Z. Do you remember, Mr. Noor? Yes. Number of electrons is equals to number of protons. That is why atoms are stable in nature. Atoms are stable because every atom contains number of electrons is equals to number of protons. But the mass of electron is not equals to mass of proton. How many times, sir? One proton is equals to mass of one proton is equals to, okay, 1840 into mass of one electron. Means how many electrons we have to add? 2 equals to 1 proton. Everybody. Yes, please. 1840 electrons is equals to mass of 1 proton. That is why we say mass of electron is 1 by 840 times. Okay, 1 by 40th, 1 by 1840 times of mass of proton. That is why it is negligible or considered, everybody. So mass of electron is what? Mass of electron is negligible. Is it okay, everyone? Yes, please.
Yes, sir.
That is what you have to remember. Okay, please write it. Anything doubt you can ask. So this is what is anode rays. So now meeting is going to end. Join. We will study properties of anode rays. Okay. So what is another name of anode rays? Anybody can tell me? Anode rays
Canal
are
rays.
canal rays or channel rays. Remember, or positive rays. So till here, anyone having anything doubt? Please let me know. Take the notes properly and write it kindly. Everyone. Nimish, understand Nimish, Gokul?
Yes, sir.
Yes, sir.
Yeah, please.